So, welcome to the last session of the conference, and I have to say that I have to judge the success of a conference from the attendance of the last session, this was a pretty good one. So thanks a lot for staying, and we are just solving a little technical problem with the presentation, but we will start. I'm Paolo Mutti, I'm the head of the Instrument Control and Data Acquisition of the neighboring institute of the ILL. And I will guide you through this last adventure for the last 40 minutes or so. T'arrives pas à l'ouvrir en mode présentation?
No, you go to the top right. It's with arrows. Is it Control Alt? Is that what people know? Control what? Control Alt. Alt. Alt.
No, it's fine.
Okay.
Okay. Okay. Hello everyone. Sorry for the hiccups, and then that means that I have to use a PDF, so there will be less animation. So there might be a lot of things going on the screen. So bear with me. Yeah, just going to take. Yes. All right. So I'm going to present what we are doing with eWorks at ESRF to bring automatic data processing at ESRF beamlines and users. So I'm Loïc Huder, you probably already saw me, but I'm still a software engineer, hopefully. Why do we need automatic data processing? Then, well, I'll go very quickly on this part because we all are aware that we have now a huge amount of data that are acquired, and the users and beamline scientists need help to process this data. And workflows can help in a sense that you probably know what are workflows, but just so we are on the same page, I'll just remind you of the definition that I've chosen here, that workflow are data processing pipelines or recipes that are composed of several steps or tasks. So you can see here an example of a tomography workflow that we use here at ESRF, where you have a bunch of tasks, one after another. You have some tasks to do specific things, such as find center of rotation, another one to do the reconstruction. At the end of the day, what you want to do by chaining all these tasks together is to go from this data, where you cannot tell anything about it, to this data, where you can actually use it and tell something about it, and then decide things for your next experiment based on this. So workflow help also for fair data in a sense that once you have this recipe, it's easily to reproduce the data, the process data from this recipe. You can also reuse it for similar data sets. You can trace back also the origin of your process data, again, tied to reproducibility. So workflows are a great tool to provide fair data. And I want to stress here that we use workflow not as an end, but rather as a means to achieve fair data and to make our data more valuable. And we are not the only one who found out this, because a lot of other people did so as well. And there are hundreds of workflow systems, and I'm not exaggerating, there are really hundreds. And some of them were actually already used at ESRF before we started eWorks. So we had a tomography workflow, as I was saying, using Orange, so to add some interactivity with graphical user interfaces. We had a custom solution called PyPushFlow to drive the experiment at the MX beamlines. So this one was also not only workflow, but more like expert system with loops, conditions. And this is the kind of stuff that you cannot really find in other workflow. And our aim, the question we were trying to solve is how can we have all these amazing features from all these different workflow, but in a consistent way so that we can provide consistent data processing with all these workflow systems and all their own features. And this is where eWorks comes into play. So eWorks, even though the name of the session is Workflow Engine, is not a workflow engine. It's actually a meta workflow system in a sense that it reuses workflow engines and can wrap any existing workflow system. And I'm going to go more in detail what I mean by that. So this is one slide where actually there should have been some animation to hide you a bit the complexity. I'm taking one example workflow here where I have some data reduction task, which is doing a PyFi integration, if you know about it, but imagine this is just one data reduction task, and then you have another task that does the saving. What eWorks provides you is a common way of defining such a workflow across workflow system. The workflows that I'm writing here as a JSON, where I can say, where I have this node that is one task, I have this node which is another task. Oh, actually, I have two of them, but just skip this one. We have this one, and then I have a link between these tasks. This representation, this JSON representation can be reused for any workflow system that eWorks support. Same way, eWorks also provide a common way of creating tasks and defining tasks across workflow system. So there are several ways of doing so. The first that I show here is an example of a task, a class task that reuse task from eWorks core, where I can define input name, optional input name, output name. So really what comes in, what comes out, and then some processing in this run method. And again, this task can be run by any workflow engine that eWorks is supporting. Here, I have another example where instead of using a class, I use a function. So that means that if you have already existing Python function, you can easily add them inside eWorks workflows. The only thing you have to take care is just changing the task type here to tell that it was not a class, actually, it's a method in this case. So eWorks also provide a set of tools that are independent of workflow system. So for example, if you have a workflow that is in JSON, you may want it in YAML, but then this is not really tied to the workflow engine itself. So that means that we have actually utilities to convert from one file format to another that is not dependent of the workflow engine that you're using. Logging of execution event. Whatever the execution engine you're using, you will still execute one task, execute the other task, and you will want to be notified if these were launched and did succeed or not. And so eWorks also provides this, and other things that I will not go into detail here. And again, to really push this point here, eWorks is not another workflow system. It is not another workflow execution engine in a sense that when I want to execute a workflow, I need to select the underlying workflow engines that I will use for the execution. And I show here two examples where first I execute my workflow by giving it a parameter using the task engine. And then I have this little box that tells me that the workflow was finished and did execute successfully. And I could do the same execution, but with a different engine, which is the PPF engine for PyPushFlow. And again, I can execute it, but this time using the PyPushFlow engine. So really, eWorks decouples the workflow definition and task implementation that I shown in a previous slide from the workflow system that is used for the execution, and that can be really easily interchangeable. eWorks also interact with established tools, such as, well, I'll just show you that any Python code can become an eWorks task, so mandatory mention of AI machine learning. Then we can also interact with the Slurm cluster to schedule workflow on the cluster. And it can also interact with our acquisition system here, which is also Python-based, which is called Bliss at USRF. And this allows us to actually bring automated data processing to the ESRF beamline. So the acquisition control, Bliss, will trigger eworks workflow, or does trigger, because this is happening right now as we speak, does trigger workflows, eworks workflows, and this can be either on local machine located at the beamline or on Slurm node if you need to do more intensive calculation. And these eworks workflow produce process data that you can really reuse directly on the beamline to see the process data. So if you want to make, again, a decision for your next scan or something like that, are saved as HDF5 for further analysis if needed, if you want to do more analysis afterwards. And then also, we had this presentation by Marjolaine that showed that we can also upload the process data to the data portal so that it is actually submitted to the data policy and can be retrieved later and explored by users that are remote. And by having this, that is running right now as I speak, datasets are processed as soon as they are acquired, depending on the eworks workflows that you want to put at the beamline. And again, this eworks workflow does not depend on the workflow engine that you use for the execution. I give here simple examples because an example is worth 1,000 words. One simple example that you may know about this is a 2D image of a powder pattern acquired with a 2D detector. And often what people want to have is the integrated pattern along the azimuth. And then you can easily do this with eworks. This is a very standard workflow that we have deployed at several beamlines here. And this is running online, meaning that as soon as this image is being acquired at the beamline, we directly have the integrated pattern, 1D integrated pattern here, that can also be uploaded to the data portal. As I said, this is one really simple and common example that we have. We can go much further, again, referring to Marjolaine's presentation this morning, where she showed that the result of workflow of MX beamlines can also be uploaded to the data portal, and this time with a bit more involved display with diagnostic, so that, again, people that are remote can do decision based on this and can really see if the sample is good or not. Yep. So eworks is now deployed as many beamline, is now deployed at many beamline at ESRF. We have a few that are in develop planned, and it's really up to the imagination of the beamline scientists here to tell us what processing they need to do, actually. And now I move to the second part of my presentation, where I want to stress that actually eworks is not only a beamline tool. This is not something that relies on a heavy infrastructure. This is actually something that you can use, there, I see you, on your personal computer. Because the eworks ecosystem is actually made of Python packages that you can easily install using standard pip install. So the core package to start using eworks is contained in the eworks name package. So you need pip install eworks. And then, depending on the processing that you want to do, you may want to install other packages that provide tasks to do specialized processing. So, for example, eworks Fluo install task for X-ray fluorescence data, peak fittings. eworks XRPD install task for X-ray powder diffraction data. This is what I've presented with the integration with PyPhi. And in fact, there are many more tasks. And these are searchable and findable on the eworks website, which is eworks.eserf.e4. We have a task catalog that is searchable, that is where we regroup tasks according to technique. And then you can search and look for tasks that can do the processing that you want to do. And then you can use this task and put them together using the different eworks interface that we provide. So there's eworks web, which is like a full stack application that you can run on your computer, like Jupyter Lab, where you can put these tasks together to do your own workflows. eworks Orange, that provides this orange canvas that is desktop GUI, that is depends on people. Some people are more comfortable with this one. And of course, the CLI, the command line interface that I've shown you at the very beginning with eworks execute, eworks convert. And there's also eworks submit in case you want to submit a job to another node, to another computer, and you don't want to execute it on your personal computer. And because we have this interoperability actually, we have multiple use cases, but we can have only one workflow. So for example, the beamline is running one eWorks workflow automatically online, but it can be up to the user to choose the existing tasks that are in the eWorks ecosystem, create workflows, do a JSON out of it, and give it to the beamline scientist telling, now I want to execute this workflow instead. And this time, this way, we can easily change the processing that is run automatically at the beamline, because it's, again, using the same eWorks infrastructure that can be installed by the user or by the beamline. It is just a matter of plumbing. Conclusion, I hope that convinced you that eWorks is a great asset to provide automatic data processing, can be used locally by users or by beamline end clusters. It can interact with established tools, the whole Python ecosystem, because as I show you, any Python code, any Python function can become an eWorks task, and the acquisition system such as Bliss for the online data analysis. And more importantly, it works across workflow system and engines. It is not tied to a single one, meaning that you can have a workflow engine that support loops, for example, and another one that has the interactivity, such as Orange. These both produce eWorks workflow that can be reused across engines. I want to say that the success story is continuing. It is now used, as I showed you, as more than 20 users of beamline. We have many exciting development to come. For example, we have this feature where we want the workflow to actually declare what kind of package they need to be executed, so that you don't need to install the package ahead of time. The workflow will tell you, if you want to execute this workflow, you need to install this package, this package, this package. So that makes the workflow way more reproducible. And we have user support by a dedicated team, not only at ESRF, but also outside. I think we have now 7 people, I think, working on eWorks. We had many newcomers, and we're really happy to be able to make eWorks grow in the next years. And I think I'm right on time.
Yeah, right on time. Thank you, Loïc. Question for Loïc.
A lot of workflow engines are adding CWL support, the common workflow language. Have you looked into that?
Not yet. Not yet. This is not a use case that we have right now. But if people want to bring support for this, then yeah, we are happy to look into it.
The common workflow language supports chaining of command line tools, which is eliminating 90% of our use cases. We could support it, but,
yes, we could support it.
But that's the reason why we don't, or we haven't. Because most of our workflows, you chain together functions in Python. You don't chain together command line tools. And the common workflow language, the language itself, doesn't allow you to express this. So if somebody would need it, we can easily make a mapping. But for us, for our use cases, it's perhaps maybe 1 or 2%. Yeah.
Okay, thank you, Loïc, again.